rope there, Carl, please. Now, in our litter rig, what we like to do is we tie it where we have tails. These tails of rope will be used to tie our litter attendant into. Now we'll need some way to attach it to the litter. Now, I've seen people use a long-tailed bowline for this, but in doing so you have to thread a lot back through it. What I prefer is, you may remember just the single butterfly where we go like this and we make a loop. It's called a middleman knot, where we do it that way. That would be just a single butterfly. But what I like to do is I tie them together. It's given us some advantages in it makes the ropes work pretty good together. You could tie them separately if you wanted to, but this is just one system that seems to work well for us for the different ways that we do it. And so all we're doing is treating this as one rope, and we're creating one bigger butterfly here. And so now at this point, we've got our butterfly here to clip our litter into. We've got our belay line, which would be our red one. We have our work line, which would be our tan one. And then we have the tails to tie our litter attendants into, and they'll have an adjustable system right into this. Let's, at this point, let's talk about some basic anchoring principles, and then what we'll do is we'll move up to the tower, we'll set up our anchor system up there, we'll talk more about it. But when we go into anchoring, I find there are a number of principles that we talk about that we'll need to go over. Vectoring, we've brought this out in the last video. If you have an anchor here, an anchor there, and you pull in this direction, and say this angle right here is 178 degrees. That's really tight. It's pretty hard to keep things that tight. And we put a 200-pound load here. Well, actually in rescue we're talking 440, maybe even 600 pounds. And so in rescue we're talking a whole new ball game other than just a single person. But out here, the force out here and the force out here is going to be a lot more. We may talk as much as, in this case, if we put 200 pounds there, we're talking 5,000. I'd have to work out the formula, but the forces out here are just incredible when you get two anchors together. And in the previous video, you'll be able to see that one. Some of the other things that we didn't bring out, though, are what we call resultant forces. Say if you have an anchor here at the top, and your rope comes up and through a carabiner and back down. Well, say if we have a 400-pound load here, and it falls a few feet, we could easily develop and turn out 1,500 pounds or more of force down here. And the force, if we were to put a pulley right here, would be about 1,500 pounds, maybe a little less here because of friction. But what a lot of people don't consider is the force up here at the anchor. Now we have a resultant force of close to 3,000 pounds up here. And so resultant forces can be a lot and actually cause this anchor to fail, because when they put the system together, they are only considering the 1,500 pounds down here. Now another one is what we call resultant angle of pull. When you put your anchor system together, think in the event of a fall, not just what gravity does. Gravity is straight up and down, whereas in a resultant fall, the anchors may be pulled one way or another. So resultant angle of pull is going to be something important to consider. Now we also, for anchoring, we have to protect edges. We often use carpet, scraps, then we use duct tape to wrap it around it to hold them in place. Another thing would be your commercial edge rollers to go over the edge to let the rope move. Now carpet is really great for places where the rope is static, where it's not going to be moving. But if you're rolling a litter across this, it would cut right through a piece of carpet. But the edge rollers roll with it and make it more efficient. So in anchoring, that's important. Let's talk about bolts for a moment. What we've done here, this bolt was placed here about 15 years ago. You can see it's the old Star Drive-In, they call it. And it has the old chrome-away hangers. At the time, they were the best on the market, but now even the manufacturer of these says they won't use them. This is called a raw bolt. One of these placed and put into the right torque with a stainless steel hanger such as this is good for 5,000 to 7,000 pounds. The hanger's rated at about 5,000 pounds, and the bolt's rated about 7,000 pounds. What we'll do is we'll drill a hole. We have an actual drill for drilling it. We'll make sure the mass of cement around it is solid. One problem that happens is people will place bolts, they'll put in an edge like this, but not think about the concrete breaking out there. So what you want to do is have a lot of mass around it to support it. and make sure that you get the right type of bolt. And once we drive this in, then we'll tighten it up, and this little wedge here will come into it and expand it. So right now what we've done is we've got a power drill, and we'll just pick out a good area. Usually what we do is, if we're out on the rock, is we'll sound it. We'll bang it to see if it sounds hollow or something. We find a good place. For us right here is we'll make one over here. We're well away from this old hole. We hold it in straight. Now there is a misconception. People think that if you hold and push hard on this, it's going to drill faster. In fact, that may slow it down. So what we do is we try to just hold its weight. One thing that we'll want to do, you notice he's blowing out the dust, and we're going to want to make sure it's plenty deep. If it's not deep enough, that's really bad. In this type of bolt, it doesn't matter how deep we go, but if it's too shallow, it is a problem. And how deep is it? Okay, now we'll have to go a little deeper. Notice there's already tape on this drill bit showing the depth, and so I went up to the tape now. I know I'm at least deep enough. And so on this type, we pull the sticker off it. We're going to take this off it here and take it apart and grab the hanger. Let's grab that hanger if we can. We'll thread that through there directly in here. Now, one thing to prevent frost wedging and rust and stuff, problems like that, is often we'll put silicone or epoxy around it. We'll face this in the direction we want it, and actually now at this point we're going to tighten it up, and to get a proper depth or a proper thing, a torque wrench is important to get it seated properly. Now, you can pretty well guess it. More bolts, you're going to have problems. If you over-tighten it, you can actually break it off. So we'll come back up here later with the torque wrench and test the torque on it. These run up to about 60 foot-pounds of torque for the half-inch, 35 pounds for the 3/8 inch. Let's talk a little bit about leverages. A general rule, I never say never, or I try not to, is not to use guardrails for anchoring. And the reason being is, if you were to consider the forces on a guardrail, say we have our 4-foot guardrail, and if I remember right, OSHA says 200 pounds is what a guardrail has to hold. So if it's more than that, you're lucky, but that's what OSHA says. Now, if we were to pull that direction, and this is a 4-foot high type guardrail, down here, if we say we pull, we'll call it our 600, well, let's call it 500 pounds for round number. That's a good healthy rescue load. And we have 4 feet. Now we have 4 times 500. And so we now have 2,000 pounds of force down here at the bottom of this guardrail. And so you can see how forces multiply real quickly and can actually cause a system to fail. Another thing is we often use what we call directional anchors. It works a lot easier. Say we're up on a catwalk and someone has fallen off the catwalk. Then here our catwalk is along here, and the person's down below here, hanging off here. And to try to put a mechanical advantage or a Z-rig through here would be very difficult. And so what we'll do is we'll end up putting a direction change. We'll come up here and go over here, and then we'll put an anchor right there. So we have our anchor out here, and we have our directional and anchor right here. Now, the question is, well, which anchor has to be strongest, this one or this one? Well, this one right here is about at 90 degrees. It has a factor of 1.41 that you have to times it by.